Hi friends, I'm Dr. Meenal and you're watching Meenal ka channel. So welcome to my channel and let's start today's video. Topic of today's video is differential coefficient and elasticity of demand. This is application of simple derivatives. So let's start. Uh, First, we start with the definition of elasticity of demand. What is elasticity of demand? Price elasticity of demand is the value of the ratio of the relative change in the demand to the relative change in the price, or we can say proportionate change in demand to the proportionate change in price. Okay, very precisely, if we suppose that demand changes from x to x plus delta x, right? Demand changes from x to x plus delta x because price changes from p to p plus delta p. Okay, then the elasticity of demand is what will be the elasticity of demand? It will be the proportionate change. Proportionate change in quantity demanded, right? Upon what? Proportionate change in price, right? Proportionate change in quantity demanded upon proportionate change in price, or mathematically we can write this as change in x upon initial x whole upon change in price upon initial price. This can also be written as delta x upon delta p into p upon x. So this is simplified, nothing but simplified form of this, and this is what? This is elasticity of demand, right? In fact, now what this represents, this is the elasticity of demand represented, represents the arc, represent one piece of arc, or we can say this gives us the average elasticity of demand over the price range p to p plus delta p, right? What over the price range p, this price range p to p plus delta p. But what we want point elasticity, that is elasticity of demand at a particular price level. We can say it p. Then delta should then what should we do? Then delta p should made to approach zero, right? Graphically or geometrically we can understand this. If this is the demand curve, right? This is initial price and quantity, this is the changed price and quantity. What is this? This is delta p. Okay, this formula is representing elasticity of this arc, this point q1 q2. What we want elasticity at a particular point. So if this delta p will tend to 0, this arc x q1 q2 will also be tend to 0 and will become a point, right? So if we want the price elasticity, we should put the limit of delta p tends to 0 in this formula. Okay, so elasticity of demand is equals to limit delta delta P tends to 0, P upon X, delta X upon delta P, or we can simply write this as P upon X. This is limit delta P tends to 0, delta X upon this is delta P, right? But according to law of demand, if price increases, demand falls. That means if delta P is positive, delta X should be negative, and if delta X is positive, delta P should be positive. That means this term should be negative. So we should put a negative sign over here, right? Negative sign. Elasticity of demand, this is P upon X, limit delta P tends to 0, delta X upon delta P, right? And if we want absolute value, of course we are always interested in absolute value of elasticity of demand. So what we will do, we will put a modular sign. Mod elasticity of demand is equals to modular sign P upon X, limit delta P tends to 0. This is what delta X upon delta P. Okay, so this is the absolute value of elasticity of demand. Okay, but since we can write this part, that means limit delta P tends to 0, delta X upon delta P, we can write this as differentiation of X with respect to P. Okay, if you are not understanding, you are not getting this concept, please refer my video. I will give the link of video in my in description box, that how it is equals to this, right? So this is what, this is differentiation of X with respect to P. So what will be the formula of elasticity of demand in the form of or differential calculus? Elasticity of demand is equals to, this is Px into dx upon dp. This is the formula of elasticity of demand in the form of differential calculus, right? And what is this? What is this dx upon dp? This is the differentiation of x. That means this is the differentiation of function. X is function of t. That means this gives the elasticity of demand of this function at every value of t, at every value of curve, right? So the next form, this is you have seen that this is the arithmetic form of elasticity of demand. This is the arithmetic formula of elasticity of demand. Okay, and this is the elasticity of demand in the form of differential calculus. Okay, now let's see the elasticity of demand in terms of marginal quantity and average quantity. So this we can also write this in the form of, like, this is dx upon dp upon x upon p. Am I right? Negative sign is also here, so this is also negative sign. So what is this? What is this? From differential calculus, this is what? This is the marginal value of quantity demanded. Okay, differentiation represents the marginal value. So this is marginal quantity demanded, right? What about this term? What is this? X upon P. X upon P. This is nothing but this represents the average quantity demanded of the given function. Okay, average quantity demanded. This is what? This is average quantity demanded, right? So always remember these three formulas: the arithmetic form, the differential calculus form, and in the form of marginal and average quantity we can calculate elasticity of demand. Numericals related to these concepts are in a different video, so I'm giving the also giving the link of this video also, so please go and check, go and learn how we can solve the how we can solve numericals related to elasticity of demand. Hope you liked my video. Hope you understood the concept of elasticity of demand. Hope you understood how mathematically we represents the elasticity of demand. Thanks for watching my video and stay tuned on my channel. Please subscribe my channel. Please share it with your friends so that they can also get benefit from this channel. Thanks for watching. Bye.